Alrighty, so hello and welcome. What we're going to take a look at here is the Skyline problem again from a few days ago, or a day or two ago. And what I want to do is I just want to take a look at the solutions, right? Because we solved it, figured it out, but I want to look at the discussion because I thought about it some more and I was like, the n log n solution doesn't seem quite as good as it could be. Really detailed and good, perfect explanation. 100 milliseconds, 10 line Python, quadratic time, linear space. I did n log n time. One priority queue, 10 line Python. Whoa. Whoa. Huh. Guaranteed, really detailed and good, perfect explanation. Do not lead. Please do not ever say detailed explanation. We're not explaining your thoughts very clear. Just posting code with some comments, not explanation at all. Okay. Post I've seen it's not obscure. Check the following link, then detailed explanation. Your understanding is almost guaranteed. Oh boy. Uh-oh. Scared. Short Java, 10 Python, Python. Ah, these are all bad. Bluntly. Divide and conquer. They're bad. The bad. They're all bad. 17 line and login. Accept the easy solution explanation. Okay, let's try this one. I like Stefan. Stefan does a good job. Yeah, and login using heap. I was gonna say you could use a heap instead of a multi-set. A multi-set's a little bit easier in my opinion. So it looks like nobody got O of n. That's what I was looking for. Yeah, I got n log n. Oh, this is pretty detailed. Quadratic time, okay. Sort the points, scan across, left to right, left edge, add, heap. Okay, so use a heap. Alright. Alright, I was just trying to figure out if anybody did something without a heap, but I think a multi-set's better than a heap, just because it's simpler. Alright, so nobody really... Okay. Maybe a heap is a little bit more efficient in terms of like just the raw time, I guess, the raw milliseconds. Dongwing 1694 is a brilliant solution, Python version. Left to right. Doesn't only keep heights, does remove them, height, right, pairs, kept, pairs. Yeah, I was thinking about doing this. I was like, you could use a heap and use tuples of height and the right solutions, but even easier than that is just dump everything to a multi-set. Excuse me. Actually uses a little bit less memory, I think, possibly. I don't know. So mine's fine. All right. I really thought about that one too. I was like, it's got to be. Where are all the solutions? What is this? How did I get to this page? Not found. Oh, I mean to do that. All right. Well, okay. So yeah, my solution was linear time. Not linear. N log n. What did we end up with? Yeah. But we're not 100%. We're like 45%. How come everybody else is so much faster? I guess using the heap is faster. That's what I'm thinking. We use a little bit more memory though because we're using, we're like doing all this stuff with the events and all that, this pre-processing that we're doing. I don't know, man. Not as fast as it could be. Maybe it's just, no, it's pretty consistently. kind of slow. It's kind of slow. I think if you use the heap, it's faster. I think that's why. That's my thinking. It's just the way heaps are implemented. Multi-set's a little bit slower to the operation of the multi-set, and you also probably don't need to like do all this pre-processing with the events. That might be part of it too. I think that's the deal. I think that's probably what it is. With the heap, it's just less machinery. It's the same asymptotic runtime, but this is kind of simple. I don't know. I'm kind of conflicted now. I'll just say you could use a heap and keep the height and the right side, so you know when you should remove something from the heap, if it's sort of been invalidated already or not. That's pretty much what he was explaining the other solution. I mean, okay, okay, it's not 100%, not as fast as it could be. Probably should use a heap instead of a multi-set, but I thought the multi-set solution was pretty simple. Yeah, I get it. All right, let me go then. That'll be it. I just wanted to quickly review that. Yeah, basically so the two different solutions would be, one, you could use a multi-set. All you do is you reassociate the inputs as the rectangle. So there's a left, a right, and a height for the rectangle. So you break each of those into two pieces. It's two events, right? When you reach that building, the x coordinate and the height associated with that, and the other event is removing the building and the height associated with that. And so you break each item into two pieces, put that into, and then you associate each event with the x coordinate. So use an unordered map of you just basically make a queue. The index, the x coordinate is the key, and the q is the value. So then you just dump all those events into that queue, and then you dump all of those into a set of pairs, a vector of pairs. Sort the pairs on the x coordinate. So now you have these events are associated with. Really, it's just a height and a Boolean, right? So it's either adding that height or removing that height. And those are associated with, each of those events are associated with a certain x coordinate, so you can scan left to right. Now you just sort your tuples or your pairs you've dumped into a vector, sort those on the x coordinate, and then process those events left to right. The idea is that you potentially have multiple spots where you're adding and subtracting heights on the same x coordinate. So that's the idea there. You kind of refactor everything that way, and then you just keep your heights stored in a multi-set. So adding and removing heights as you need to, and because the multi-set's already sorted, and it takes n log n time to add, logarithmic time to add and remove, you end up with total n log n time, obviously O of n time pre-processing, and then you're gonna each time you add after you process all of your events, there's sort of a highest height left over in the set, and you add 0 to the set as well, so there's always guaranteed to be at least a 0 in there. You just take the highest height in the multi-set at each of these points, and that's it. That's all you need to do after processing all the events. That's the algorithm that I wrote, just like explained in short. The heap version is very similar, except instead of a multi-set, use a heap. And what you can do in the heap is you could store the height and the right side, so when the building's going to be removed. And then the way that works is now you can store everything. You can add each building to the heap as it comes. You do still want to scan left to right, and you just have to add to the heap the height as well as the right side. So when you're processing the heap, you can tell whether or not what you're looking at has been invalidated or not, and you use that just to check. At each point, you check what the current highest height is, and you either add or remove. So you don't remove any elements. They actually get removed automatically by being invalidated as you move left to right. But you add elements by, when you see an item, you can add it to the heap. You do need to be careful when you remove a height. So you still kind of do the left to right events. I mean, I guess you could still do the same event processing. Really, it's just a container that you're sticking your data into. Instead of a multi-set, it's a heap. You still kind of want to do the same deal with the events where if the height is not the one at the top, then you don't pop it from the heap. But if it is the one you're moving, when you're moving buildings, right, how you process the two events slightly changes. So adding buildings is just add it to the heap, but now you want to use the triple. You do want to actually add the right side, and then removing the building, you just remove the height, and you check what's on the top and say, okay, if the height that we're moving is the same as on the top, then pop that off. Otherwise, don't do anything. Right? That's how you remove it. And then what's going to happen is if you see anything on the top when you're processing events that is already invalidated, in other words, the right side of that pair is to the left of where you are scanning currently, then you would pop that off the heap as well. So you just slightly modify how you handle the events. But I think the main issue is probably like how you set up that event handling. I think if you don't use a multi-set, use a heap, you can use a little bit less machinery to actually process those events. It's a little awkward. I don't know. I don't know if you can not process the right side events. I think you have to. I think that's the thing I'm kind of hung up on. You only really need to. So here's a trick. So this actually might be like the optimization. Maybe you don't need, with the heap approach, you don't necessarily need to split the events that way. You only need to process the. You only need to process the left sides and take a look at what's at the top of the heap and check whether that value is invalidated or will be valid. In other words, like what you could do is go between the beginnings of buildings and check whether what's on top would fit between those two buildings. Meaning the building that's at the top would end. Then you do process an extra event in between where that height gets popped, and then pop all the other heights that have been invalidated. That's the way to do it. That allows you to do O of n, like the very efficiently process the initial input. In fact, you don't even need to sort the initial input if you do it that way. You're still going to get n log n because you're going to dump everything into the heap, but you can add things to the heap as you go and remove things from the heap as you go, as opposed to doing a single pass, a couple of single passes. So I think that's why it's more efficient, because I'm doing at least 2 passes and using a lot of extra like underlying processing, whereas you could do this in 1 pass for the heap. Got it. I was trying to figure it out. It's like, how come my solution's only 50%? Why is it so slow? It's because you can do it 1 pass with the heap when you're between buildings. So before you process the next building in the array, you want to check if the next building begins before or after the building that's on top of the heap ends. If the building on top of the heap ends, you want to process an extra event for that popping off of the heap. If it doesn't end, then you just go to the next part of the heap. That's super clever. That's super clever. All right, got it. Yeah, I was like, I don't know. I don't think there's a way to do this in linear time. I might get asked this question in interview. I'll be upset. I'll be frustrated because I had studied it already, and you just use a heap, and you can do some use tuples instead of just integers in the heap. Fair enough. Fair enough. I like that. It's good. I'm not gonna code it, but I think I got the idea. I think it works. So we can move on. But yeah, thank you for watching. That's interesting question. Interesting problem.